Hello everyone, and thank you for making it to this session wherever you are. I know getting a common time slot that works for everybody is difficult, but I think this is the best we could do. This is the second session that we are doing in terms of Teuthology training, and this one will be focused on analyzing Teuthology failures, particularly what do we do after we schedule a run, or what do we do after we start running some tests? I know there is already a learning curve involved in getting you set up with Teuthology and having to understand what a suite means or a work unit means or getting SEPIA access and all that stuff. But once you get over all that and you start running a test, you need to be able to understand what those tests are doing, whether the test is a pass or a fail. And I'm going to try and cover some of those details in this session. So as I shared the Etherpad in the chat, the first few points that I have, I feel are basic guidelines or basic things that everybody needs to remember when they start reviewing Teuthology runs. I feel it's a responsibility that every developer or anybody trying to review Teuthology runs has, because what one person does impacts what the state of master or whichever branch they are running tests on is going to be on the next day. So you need to be a little more careful, and I think if you remember these few things, you're going to be good. So if it helps, I can share my screen. Can everybody see my screen?
Yep.
Yes.
We can hear you.
Cool. So let me just quickly go over this because we'll probably be going over all of them in more detail later on. First point is every failure needs to be reviewed. We cannot take anything for granted that, okay, we think something is something and so we don't look at it. So every failure, when I say failure, when you run a Teuthology run, n number of jobs, m out of n have failed. Why have they failed is something we need to analyze. And to do that, we have ways that we will be going over later. Second thing I want to mention is when you do a test run, a lot of times you'll see there are failed jobs and there are dead jobs. There is a minor difference between them, but both of them fall under the bucket of failed runs, means something has failed, something is not right. The difference is, if we have to go into the details of failed versus dead, a dead job is something that does not terminate properly within the time frame. So it just keeps running until Teuthology runs actually hit their timeout, which currently is set to 12 hours. So if you see a run that finished close to 12 hours, it means it was a dead job. It will be, we can just quickly go over an example to just show you what a dead job should look like. Let's see, maybe we get this. So this when I say when you do a Teuthology run, first place you have to look at is Pulpito. If anybody is not aware of it, this is the place to go. If you see, this is the URL, and anything that follows is the name of the Teuthology run that you've scheduled. It has details of your username, when you scheduled it, the suite you ran, the branch you ran, all that kind of details. But the idea is that you'll get an overview of how your test run did in this dashboard. Now you have this category of failed, dead, passed, total, blah, blah. When I was talking about dead jobs, I only talked about this. So when I say it's a dead job, you see the runtime here is close to 12 hours. This is what implies that this job did not terminate in time, and so it kept running until Teuthology handlers killed this. So if you see a run like this, you do need to look at what was going on and why it went dead. So yeah, that's why I have it in bold letters, because a lot of times it's not clear to folks whether dead jobs need to be reviewed at all or not, because there's some impression that they're only caused by infrastructure issues or some other randomness, but that's not true. Moving on. Then there's help along the way. When I say there's help along the way, you're just not, thrown to look at all kinds of logs and all kinds of daemon logs and figure out what's going on, or like grep through thousands of things. There are tools that are already present that can make this process easier. And there are three things that I've listed here. First one is Sentry. I'm not sure how many of you are aware of Sentry, but Sentry is a tool that helps us gather similar kind of failures and show you a history of when an event, when I say a failure is marked as an event in Sentry, and when an event started occurring in Teuthology. And it has things like which branch started failing, or which distro started failing, when it started failing, all that kind of stuff. So if we want to quickly look at what Sentry looks like, I'm just going to pick one sample, because every I think except for Teuthology, dead jobs, you will have a Sentry event like this. When you click, what did I do? I just clicked on this and I went to that particular job. So as you can see, I'm looking at one particular job now. So these are the stats of that particular job. This told me what job was run, what test was actually run. And here you see there is the details of the log, and there is Sentry. So when we click on Sentry, what do we see? You see another dashboard opened up. Now going back here, we were interested in something like a command failed error, where it was trying to look for something. It was trying to look for some versions and making sure that the number of versions was 1 in that total entry. That's not important, but what is important here is you can see that it is tracked here as the same branch name. You'll see that same error is shown here as the exception that was caught that was used by Sentry to group this particular failure. And you have all kinds of details about what the config was and where the logs are and all kinds of things. Now, I think what is the most important thing here is you see here, this right part here, last 30 days, it tells you there are 2 occurrences, first seen, last seen. This is what helps you figure out if a particular failure that you're seeing is new or not. Especially for unique failures, this is very helpful, which I will talk about what a unique failure is in a bit. But this events part here is something that you can go look at, and it will list all the similar failures that have been seen in Teuthology over time. So for example, you are reviewing a run and you see a failure, you click on the Sentry event and you just see one event, like example this should ring a bell in your mind. Why? Because this means that this failure has never been seen. There could be 2 reasons. One is that this never appeared in somebody else's Teuthology run because of whatever reason. The test was never exercised, it was a race condition, blah, blah, blah. You can think of whatever reasons. Or the most important thing, that the failure is related to your branch. Stuff that you're testing is related. So this is a clear indicator, litmus test, I would say, where you know that you need to look more and not just give up by looking at the Sentry event. A lot of times Sentry events will list a bunch of things. Then you get more confidence that, okay, this may or may not have been the same exact failure, but you can go and look at the other failures to verify whether somebody else also saw exactly the same thing or not. So that's the whole idea of Sentry being a help in this process. Now, there are a lot of other things that you can do with Sentry. I think that will take a separate session on its own, but I just want to touch upon this in terms of what I was just talking about. There's help along the way. Okay, let me just stop. Any questions here? Anything that was not clear? Okay, doesn't look like it. Then I'm going to be moving on. Second thing, yeah, go ahead, Josh.
One thing to mention about Sentry is that you can to log into it, you can log in with your GitHub account, and once you join, you can add yourself to the CPA project to be able to look at these failures in the CPA lab.
Yeah, that's important. Yeah, you need to have so as you can see that I'm part of some CPA organization or CEF or whatever that is. So I think that's something we also need to document, what you need to get access to Sentry.
Yeah, there's nothing special. You just need to, this is the first time you click on one of these Sentry links, you'll be taken to a page that lets you log in. There's a button to log in via GitHub.
Mm-hmm. Okay, cool. Then that's simple enough. All right, then we're going to be talking about scrape.log. So this is the PR that introduced this concept of scrape.log. I'm not going to go into details. If you want to look at this, but what the idea is that there is a script that runs at the end of every run that you do and tries to group similar failures to make analyzing these failures easier. Now, earlier this was a standalone script that people had to run manually. But with this particular PR, what we have done is that we now have a scrape.log which gets collected in your job along with the logs. So for example, if I pick this, I'm going to now show you where this lives. So here what I did was okay, I'm going to be covering this later, but let me just go over it. So I am now in I have logged into Teuthology, and I was initially in /ceph Teuthology archive where the logs, all the Teuthology logs live. Next, what I did was I just used the run name of that particular Teuthology job and I CD'd into that directory. Then I can now see, if you see here, I see all those, all the 361 total jobs here. So each of them have details about all those runs. Now looking at scrape.log, you see here there is a file called scrape.log. So this tells you, it basically does a post-processing of all the failures, and it tries to give you a summary of how many distinct failures were there and how many dead jobs were there. As we saw, there was one dead job, so it has said that there is one dead job. And the grouping mechanism works in a way that you'll see it. So I'm sure it must have been covered in the last session that there are separate facets that are used when a Teuthology run is scheduled. So this script also tries to find an intersection of which are the common facets that are present in a common failure. So that is what is the idea behind this, so that you can figure out just by looking at those if there is something that is directly causing this particular failure. For example, if there was some, let's just use a simple example. So this debalancer on, this means that the balancer module was on for this particular test, right? And if this particular failure that we were seeing was directly related to the balancer, then it clearly tells us that, okay, the balancer was on, therefore the failure was there. If there are other examples we can see that, there's an object store, blue store, something. And if we, let us say, had a failure that was not related to blue store directly, then we could, narrow down or eliminate things that are not directly related to a particular failure just by looking at these facets. As if you keep going down in this, it tries to, as you can see, there's one failure, this means that it just found one job with this unique failure. Here you can see there are two jobs that it tried to group together, and it has listed down all the intersection of those facets. As you become more familiar with Teuthology, facets, and what tests are being run, this kind of helps in analyzing it. And in particularly for me, things like this stand out a lot. Like if there are 4 jobs that are failing in this same ceptool test.sh, clearly there's something wrong going on, right? If there is one random failure happening somewhere, this in my mind may be something sporadic or something which is not causing a whole bunch of failures. This clearly tells me that something is causing a whole bunch of failures. So things like this are like small hints that you can take from the scrape.log before you delve further into analysis of logs. So let's go back to the pad, and finally we've got yeah. Go ahead.
So it's possible to reach the log, scrap log via web GUI. Just enough to click on any Teuthology log and delete in URL the.
No, I don't think so. You'd have to log into Teuthology. Because it's
No,
like in the.
Just try it. Open any log, text
really?
log. Yeah, just.
From here?
Yeah, click. And go to the URL address.
Mm-hmm.
And remove the Teuthology log name with the job ID. No. Run should be present. Like this.
Run should be I just removed this, right?
Yeah.
This is
and click.
Okay.
And click. And click upwards. The script log is kinda in the run.
Perfect. Yeah. Cool. Okay, perfect. So yeah, this is awesome. I never used this mechanism.
Maybe
so I didn't know
it is a good idea to add direct link from the web GUI. But
that is it should be somewhere somewhere here, just where the overview of the run is, so that you don't have to go through this. But
You're here. Please do.
Was there a question or something? Maybe not. But yeah,
it should be added to the UI.
Yeah. Okay, thank you. That's a very good point, and I think just having a scrape log here will be very useful. It also makes it more obvious that there is something like scrape log now. I have to do a session to explain to people that there is a scrape.logs, but anyway.
Yeah, of course, log into the Teuthology server is sometimes make more sense because it's way faster to grab logs.
Mm-hmm.
That's in order to figure out some more details. Otherwise, because logs itself can be very huge.
Yeah. I mean, I see it as like I'm not saying that one can replace the other, but this can be just like a one step closer. If somebody, let us say, does not have SEPI access for whatever reason, they can quickly look at scrape log and say, okay, is there something that's obvious that I need to be worried about? Somebody's looking something on their phone, maybe even there.
Yeah. Sorry for interruption.
This is a good point, actually. Thank you. All right. So, okay. Any more questions or any more discussion around scrape.log? Okay, let's move on. And the final thing that I have added here is a Redmine tracker. So this is going to indirectly help you analyze failures. When I say indirectly, it's kind of like when scrape wasn't there, or like this is a poor man's scrape. if you see a particular failure and you want to make sure that it is an existing failure, and if scrape is not useful, you can go and search for some keywords that you're seeing in a particular failure and see if there is an existing ticket, open ticket, and an open relevant ticket. I mean, like, same failure could have been caused 5 years ago and happening now again. That's not relevant. If something has happened a week ago or a month ago and you're seeing it, that makes it again clear that the failure you're seeing is not related to your test run. And at that point, what you do is you update the Redmine tracker with the test run that you saw that particular failure in. What this helps with is the person who's going to be fixing the bug or analyzing the bug will have more data points to go look at. That's kind of the whole idea. And I think everybody's aware of Redmine Tracker. There are separate components, and component-wise, you can do simpler search as well. So I think those are the three things that I think are tools that you can use. After that, I want to just go over 2 points before we go into more examples. Every failure needs to be tracked. When I say every failure needs to be tracked, it's just for the same purpose that I just described, that if you see a failure and you analyzed it, you determined that it was not related to your test run, you don't want the next person to be doing the same thing. So you want a tracker where you analyze the thing and you say, okay, this XYZ events happened and therefore this failure happened. So the next person who sees this in their run can just go look at it and say, oh, I'm seeing the same thing and my branch has nothing to do with this failure. So that saves a lot of time. So it's more like a symbiotic process. We have tried to help each other by just creating these tracker tickets. Also, it gives you a real view of what failures are there in a particular branch. Because if you don't track things on time and you try to track it after a month, it becomes difficult to even figure out. For some failures, okay, you can figure out when they started happening and things like that, or you don't even need to see, you can go fix it. But some things, especially with Ceph and Rados, I've seen it's very important to understand where a regression was introduced, and tracker issues help with that, especially when Sentry is not being very helpful. Next thing is differentiate between noise and real failures. When I went over all of these things, the one thing that I did not cover is a lot of times there are things like, some packages did not install properly, so there was a failed job. There was some SSH connection error or something like that. The test didn't run. These, in my mind, are kind of noise because the test actually didn't run, but it was supposed to run, but you still see those as failed. So you should be able to clearly identify such things just by the failure reason you see, and the best thing to do is to rerun such jobs. There is a -- rerun option in Teuthology suite that goes and reruns failed, dead, failed and dead, failed or dead. So you can do that so that you make sure that the test that was supposed to run actually runs. But those are actually noise. And real failures, everything that we were discussing earlier was real failures. So then again, the next point here is about failure injection. So a lot of tests, especially thrashing tests, inject failures. So when you see that there is an OSD that we are not able to communicate, okay, sorry, I'm being biased with OSDs and Rados, but I think that's the example that comes to my mind. So if you see that there is an OSD that suddenly we cannot communicate with, and that just shows as a socket closed or something like that in the Teuthology log, there could be several reasons for it. There could actually have been a crash on the OSD because of which it died, and that can be confirmed by looking at a corresponding crash in the Teuthology log. And sometimes it could also be because we are trying to inject a whole lot of messenger failures, messenger socket failures. in those conditions, it becomes a little harder to just diagnose from the Teuthology log as to why that happened. In some places you'll see that we are waiting for even for monitors, we are waiting for monitors to form quorum, and due to failure injection, there is one monitor that just gets repeatedly declared as down, and therefore the test fails because monitors did not form quorum. So this again is kind of noise, but to determine that it is noise, you need to go an extra step to check whether the test was actually injecting failures or not injecting failures. That's one simple thing to verify. If you do see that there were messenger failures that were injected, there's this, at least in some places, this is the keyword you'll see, and there's a directory that we symlink everywhere that has different kinds of configs that we apply to tests to inject messenger failures. If you see such a thing in the test run or the description, you know that there was injection of messenger failures, and then you go do the next step and verify where that happened and whether that was the cause of it or not. Now, again, the next part of it sometimes is complex. I'm not going to go into details, but something to look out for. And if you're not sure about things, it's good to discuss with other folks in the team and look at stuff together to verify. But this is also sometimes a reason for noise. And I think I already went over the package install connection failures. Sometimes fail to lock machines. I think the good thing is these days we don't have such problems because the new dispatcher is working very well, at least has solved this problem very well. So just the whole point number 5 is about, there is sometimes noise, but just try to be aware of what buckets they fall into. Any questions before we start looking at some more details? All right, I'm just going to move on. We can do questions at the end, maybe. So here, what I have is kind of Teuthology runs. So I've just, there may be multiple others as well, but I've just tried to put it into 3 broad categories based on which your analysis may vary a little bit. And, in some cases, you have to be more careful versus in some cases, you have to look for outstanding or open issues. So like, for example, the first one here is a WIP branch, right? WIP branches are what, we developers used for validation of PRs on master, or it could be any other table branch as well, for backports. So these are usually runs where you like, at least example in Rails is like around 350 jobs or plus, but these are usually larger runs. So you have more failures to analyze. But these are the most common types of runs that are done in Teuthology by developers or anybody. And also these are the ones you need to be more careful about, because this is where new stuff gets merged into the code base. So if something is problematic and we merge it, then on we have introduced a regression. So that's why I have mentioned here that reruns are encouraged. If a lot of times there is some lab issues, the lab is going out of space, or there are network issues, things like that. In those cases, if you have a run where you have 50 jobs have failed, out of which 40 were because of noise, I personally would not encourage anybody to merge a particular PR with that state. I know it's cumbersome. You need to wait. You need to rerun. But I think it's better to be safe than sorry in these cases, because that may affect the state of your baseline runs or baseline, how your master baselines or your Octopus, Nautilus baselines are doing after that. So that's why when I say rerun, it's the same -- rerun option that's there in Teuthology suite that is encouraged to be used. Next here is what I call a baseline run, or like, you take the tip of a particular branch and you run a suite against it. These are, usually done in our nightly tests, see what the state of branches or how our test suites are doing. It is also used for QE validation for our point releases. So if you're aware of the point release process, you'll see URI finalizes one SHA-1 that we decide is going to become the tip of the point release that we are going to be doing, and that tip gets frozen, and he runs a whole bunch of suites on that tip. So in those kind of runs, what we are trying to see is things that have not been caught earlier in our WIP branches because of whatever reason. There could be some bugs that only pop up due to a race condition. So it may not have popped up the first time, but may pop up this time. Or other things that are associated with probabilistically injecting failures. So if you injected a failure with some probability, you did not, there is all our thrashing tests have probability associated with, how many OSDs are being brought down or when they are being brought in. So timing issues, again, it has got to do with race, but, some things that may not happen every time or not very repeatably failing can pop up in these runs. So these, I would say, are generally used for baselines, and they help discover bugs that have not been discovered in our WIP testing. That does not mean that, if you see a failure in this run, you don't create a tracker. You do create a tracker and try to figure out where it merged, where the problematic PR merged. Again, this is going to be more difficult because you're kind of retrospecting as to what could be the root cause of a particular failure. But in general, Sentry and Tracker and everything are going to help with this. And finally, third one, which I call developer-centric, is these are usually smaller batches. So like the example, I didn't go over this example, but I mean, it's just like, the previous one, which I was talking about baselines. So this is a run that has been done by me, a Rados run on Pacific on this particular, on 22nd. And this is what the state is. As you can see for yourself, and a lot of nightly jobs that are run look similar. Go over this example. So this one is a developer-centric run. What I would say is because a lot of times developers want to reproduce a particular bug or verify that a fix for a particular test is working or not working. So you would not run the entire Teuthology suite at that point. You will try to run one job or like a subset of tests to see how your fix is doing or how reproducible a particular bug is. So I added this example here just, I was trying to reproduce a particular bug. As you can see, this where the entire job description is. And so I tried to use this and run it on Pacific. So my idea was that I saw a particular failure on master. Let me see if I can reproduce this on Pacific or not. And that's how you can see that I did reproduce it once out of 10 times. This was the same run using the -N option, just trying to reproduce a bug. So these ones are more developer-centric. You won't see these run often as baselines or anything, but are useful when you're trying to debug something. I think that those are kind of the points I have here. Yeah, the other thing to mention is that you can always use this suite repo and suite branch. So basically, you can run your test changes against existing builds so that you can make some tweaks to the test or add extra debugging, change some config, and then run those tests without having to build a new branch. Just use your QA changes. I'm sure this must have been covered, but I thought I'd just mention it anyway. Okay, so before I move to the next section, any more questions?
So now I had a question on, for example, you're talking about that WIP branch, right? And supposing a developer sees some failures there, would it be a good idea to compare that against a baseline run, for example, a recent baseline run? Would that help in? Yeah. So, how would a developer go ahead and find the most recent baseline run? Would we have to go through the list of jobs that are already run on Palpito, or is it could help if we mark the most recent run somewhere that we can quickly go back and check? Is what
so the easiest way to do this is go to Palpito. Like I'm trying to look for Raiders, so now I went to Palpito and I went to Suite, right? Raiders. So now I have all the Raiders runs that have been done. Now let us say you're interested. There are two ways to go about this, right? One way is to look for just nightly runs. So when I say nightly runs, so we have these automated test runs that are done against master Pacific all stable branches at some frequency where you can by, let us say Pacific. You'll see any user, when you see a user Teuthology, these are all Teuthology runs. So you can go and look for the latest one here. Like the latest here I can see is 25th, and you can compare your run against this one. Or if for whatever reason you don't find this a latest run, or it didn't run for whatever reason, you can also go and pick. Let us say you want a run on master. You can see that Sage was doing something on 25th, again, yesterday. This is going to be more less reliable because he may be testing some batch which may have issues. So a lot of those failures here may be related to that. But this can give you a rough idea of what you are seeing, is that, if it's related or not. So to compare, if you're seeing, let us say, an object store tool failure in your test run, and you want to see if your batch is the only one that saw it, you first go to Sentry, you don't find it. You second go to Tracker, you don't find it. Third, you go to one of these runs, latest runs that have been done, and try to look for, the failures. And yeah, if you see the failures, you expand it. And if you, let us say, see some object store tool failure exactly the same as what you're seeing, you go and look at the Teuthology log and compare it. If you see the same thing, then you get an idea of whether or not your failure is related to your branch. Does that answer your question, Sridhar?
Yeah, thank you. Yeah.
No problem. All right. Any more questions on this? If not, then I'm just going to go to the steps involved thing. Now, again, when I have listed out some steps that I tend to use, this may vary for every individual, but the high-level idea remains the same. So what I've added here is an example of a Teuthology run. I already went over when I say run, there is a run name associated with it. Here, this is the example. Step one, as I said, Palpito combined with Sentry is your step one of analysis. We went over what Palpito looks like, what Sentry does. So see one failure, what am I doing? I'm just clicking on this. I'm seeing, okay, Sentry event is present. Now I go and look at the Sentry event. If I find something useful, I'm going to be like, this is the test tool.sh failure. Okay, there are a whole bunch of failures. This should make me like, okay, I'm not introducing, it gives me some level of confidence that, okay, there is some existing failure. Again, this is not the end of the story. You need to go and verify for yourself what these exact failures were, but this is just a guideline. combine, yeah. So step one of analysis is this. Then what we do is analyze each failed dead job. There is some good documentation that Deepika added to the existing documentation fairly recently that goes over details of what exactly triaging a cause of failure should look like. You can use this as a reference future. I'm going to be going over all this, so I'm not going to spend some time on this documentation now. So when I say analyzing failed and dead jobs, things that are involved here, you need SEPI access to SSH to Teuthology. That's, I think, very important. Everything cannot be done using Pulpito. It's just a good step one, but that's not where things end. Second point here is just what I told you earlier, that when you CD into when you CD into this run name, you'll see all the jobs. You have scrape.log for your help. So this is kind of point two, which I've touched upon earlier as well. Now I think dig deeper is the part that I want to focus on in the last 15 minutes or so. So when you looked at step one, you looked at Pulpito, Sentry, things are not clear, and then you go to the scrape.log. You got a better idea of things, but you're still not sure about things, right? You saw that, okay, there was one failure that happened 4 times, but what is that failure? What does the exact failure look like? For that, you have to look at Teuthology.log for each job. When the failure reason is not clear. When I say failure reason is clear, it is like, okay, SSH connection lost. So we know that was, you don't have to go and look at, what crash happened there particularly, or like something did not install something. Those messages are generally clear. So you don't need to waste more time. But when, command failed, or like there is a crash, OSD, something crashed, you have to go and dig deeper. And so that's why I've written that when the failure reason is not clear from step 1 and 2, looking at Teuthology log, in my opinion, is mostly recommended. I do it all the time for every failure that I see. Even though I can see things and judge sometimes, but I always want to make sure I'm not ignoring anything. So I have an example here that I want to touch upon, where I'm going to show where step 1, 2 were not enough. So this is a job which you can see was a dead job because it ran for 12 hours. It was doing a thrashing test. And the failure reason, when you see hit max job timeout, this also indicates that it was a dead job. Now, as you can see, there is no Teuthology, there is no Sentry event associated with it. So we cannot use Sentry. We need to go into this log. So that's what we will try to do now. So I have looked at this log. I know it is huge, so I'm just going to be using less. I usually tend to use Vim, but what are the first things I'm going to try to do when trying to look at this log is look for traceback. So as mentioned here in this talk, at this point here, to identify the cause of a failure, you need to use some of these keywords. And in my mind, traceback is the first thing that will give you at least 50% of the failure reasons can be reached by just searching for traceback. But this one, I picked this example because this is a classic example where you need to do everything to figure out what is wrong. So what I see here, when I search for traceback, it just tells me OS error, socket is closed. Now, this is the case where you should not assume that there was an SSH connection error or something. This is a socket is closed, OS error. This is clearly coming from an OSD where something may have gone wrong. Now, we need to figure out what that was. So we try next things. So what do we try next? Failed, caught, segmentation fault. Now I am going to search for failed and see what happens. And I know it's not going to come up, so I'm just going to give up on that. And got stuck now. Okay, this is kind of the problem with huge logs. There is no, so far we didn't find a symptom of failed, but if there was some failed, we would have found it. Now I'm going to search for caught. So there you see there is an OS. So this tells me that there is a backtrace here. And this, if we keep going up, this tells me that there is OSD2 on Smithy 061 that has crashed with a bad allocation problem. And this is the entire backtrace you see. So this is a perfect example of a job gone dead because of an OSD crashing, but the Teuthology not terminating, the Teuthology job not terminating in time, and you've got a 12-hour worth log. I saw this. What do I do next? I try to see if there is an existing tracker or not. So thought I had the tracker name there, but maybe not. Just going to use this and see if I see any recent tracker issues. This is something I tend to use, and this is just my email. And if you see, I found a first hit, which tells me that there's this tracker issue where somebody else has logged this, and they had a similar bad allocation issue. And there are a whole bunch of instances in the RGW suite, and there's a related ticket, which also has a bad allocation problem, which has been tracked since 6 days. So if I were, this is Sridhar's run. If I were Sridhar and I was looking at this Teuthology log and I saw this, I saw the tracker. At this point, I should move on because I know that this is a track failure, not caused by my test change or like my PR that I'm testing. But if in any of this, if I was not able to find a tracker and I did not see a Sentry event, at that point, I need to dig a little deeper, verify whether that crash could have been caused by the PR that I'm testing. If I'm sure, I go create a new tracker issue for it, and that's all. I mean, when you create a tracker issue, you add the Teuthology run. You add, sometimes we try to also add the description. Like if there is a thrashing test, so we add the entire description that you see, so that next time people look at it, it's just easier. I mean, you don't have to do that. It's not a must. It's just easier just by looking at it. Oh, I saw it also, and I also saw it in the thrash test. So
yeah, I'd emphasize even if you see a tracker that already exists for this issue, it's helpful to update the tracker to note that it's occurred again. We can tell how frequently and how often when this is occurring.
That is very important because this is the clear example. You can see what we have done. This is the history. We saw it first. We updated it. Somebody saw it. They also marked it as related. So it just makes debugging easier. We know that this is spread all across, not just in the radar suite. Now there's another ticket that got marked, and then the analysis. And we keep, you see that the issue started maybe more than 9 days ago, but we still keep updating the tracker so that we have more data points to analyze things. So I think what all I discussed is almost written here. If you want to go back to refer, things that I also want to cover next is the further analysis part. So I want to just quickly do an LS here. So when you are in the run and you are looking at a particular job, you have a Teuthology log here that we've gone over. There are a few other things here which may be of use to you, particularly this one, This is the original config of the test that was run, and this tells you all the configuration, all the details that were used, even the roles and everything that was used for that particular run. So this can be used to reproduce tests even locally. So you can just use this original config and use it to run against a locked machine, or even not a locked machine. This can just be used as a framework to run a test. So you kind of freeze the configuration, because as we just discussed, that there are a lot of things that are probabilistic, and next time when you start a new run, you may not land up with exactly the same values. This ensures that you have exactly the same configuration when we want to run exactly the same test again. So this is something to keep in mind. There are other things as well, but I think the other important thing that I want, this does not have. Anyway, I'm going to show one more thing. I'll pick something else. So here you can see we have similar stuff. There's just one thing extra, which is this remote directory. So when you have a failure, there is this remote directory that gets created. What it has is it has all logs from corresponding daemons that were run in that test. You also have core dumps. You have crash metadata. You can just go over quickly and see what all is there. So as you can see, this test was run on Smithy 121, so it just creates a directory of stuff that it has archived from that. So there are a bunch of directories here. The most important things that you'll end up using is the log directory. It has all the logs, zipped logs. The last few you can see are the ones, like for at least for Rails developers, these are the ones we care most about. So you can go look at raw logs, copy them somewhere, look at from this place or whatever. But this is one useful piece of information to know. And there's this core dump directory. As you can see, there is a core file that is present. So this can be used for further analysis of the core dump. And next, we see crash. This is some crash metadata, which is also used by the crash, that is collected by the crash module. We have stuff like, done log meta. Log is useful to tell you where the crash is happening. So this will have some additional, just when the crash has happened, this will have some additional debugging just before the crash happens. So this sometimes is useful because a lot of time developers want to see what happened, 100 lines above where the crash happened. We don't care about the entire OSD, zero log. We only care about last 200 lines. And this is very, it's smaller, easier to open, easier to copy, easier to move around. So something to keep in mind, that you can take a look at this one in some cases. Rest is like, meta is just the metadata of this is the structure of the crash reports that we see as well. So if you have other information, I don't think you need to look at this. Okay, going back. I think I've covered everything here. Due to a lack of time, I'm just going to quickly go over this last thing that I have. Instances where Sentry is useful and not so useful yet. So like for this example here, this This is an instance from yesterday. So there's this PR that was being tested by Yuri. Here, I have just pasted the exact job that I thought was of interest. So you see there is a Sentry event associated with it. So when I was reviewing this, I went to the Sentry event and I started looking at this particular ceph-tool.sh failure. Now, the good part is this is a command fail error and it has a unique test name, work unit name. So you can see that this has this history of events which are starting probably 2 days ago. If we go and click here, what Sentry helped me understand was, if you see, this is the same failure that has been seen in these WebStar branches are all master based, but if you see in Pacific, this is the sole branch, this is the only branch that has seen this failure. And if we go back, this was the exact branch that Yuri was running. So this is a clear indication of something that has never been seen in Pacific, is being seen in Pacific, that Sentry tells us. So we need to make sure that the PR is related or not. And turned out that it was. So this was a patch that merged in master and was getting backported. So as you can see, I created a tracker for it, and it turned out to be related. So at this point, we didn't have Sentry. We'd have to, go through a bunch of extra hoops to understand whether something is related or not. But this clearly helped us avoid a new regression in Pacific. I have one more example here, but I'm not going to go over it now because of lack of time. I'm just going to show you things where Sentry is not so useful yet. Like here, it tells you that there is a failure in test health history. So I would assume, just by the previous example, there's a unique test name. I should be able to group everything. But there is some things that we need to fix in Sentry to be able to also consider or capture runtime errors correctly. So here, as you can see, if I go to events, it does not tell me, it is not the same health history failure. It has a whole bunch of things that it has grouped, which are probably not useful. In these kinds of scenarios, you'd have to go and look for tracker issues and look at the Teuthology log to see what's going on. We are hoping to fix this or address this part as well. But as we stand today, we should be cautious about not using Sentry in these cases and relying on Sentry in the first example, or things that fall in the first category. Okay, this brings me to the end of everything that I had. And now I would really like to open it up for questions and discussion, if we have time for it, Josh.
Yeah, maybe just a quick 5-minute discussion since we are heading into the performance meeting pretty soon now.
Okay, any questions?
We can also have more discussion next week about this.
Sure, absolutely. Anywhere, I mean, we've got IRC, we've got email, we've got everything. Feel free to ask questions. But I hope this is useful, and next time you analyze something, it should be, teeny bit easier. All right then. Thanks everyone for joining.